Alright guys, welcome to 2023, our first video of the year. I even had a theme song and everything. Check out my awesome hairdo that I've got for you for this first video of the year. Are you so excited to be watching math videos again? Shout outs, hit that like button. I don't know how to do this YouTube thing. Like and subscribe, share this video, comment down below, all that fun stuff. Oh shoot. Hold on one second. I'll be right back. Alright, I'm back. I lost this tip for my stylus pen, so I had to go find that so I can write on this screen while we go through stuff. So we started talking about equations in class, and we're going to just get a little bit more in depth in these videos. And I'm going to try and not take too much time, but there are some things you need to know because they'll be important for all of our equation solving, which we're going to be doing a lot of. And you'll do a lot in algebra, algebra 2, all your math classes. You're going to need to know how to solve equations. So we can solve, and we looked at balance scales and like algebra tiles and how each side has to be equal. And so when we solve equations algebraically, we're using properties of equality. So let's just look at the, we're going to start with this section with just the addition property, and then we're going to add some other properties in later sections. But for now, the addition property of equality states that the two sides of an equation remain equal when we add the same number to each side. So if A equals B, and I just add a number to both sides, we'll call that number C. If I add C to both sides, then these sides are still both equal to each other. And we're going to use this property in this first section. Actually, no, these are one-step equations, so not just addition. So we'll use several of these properties for these one-step equations. We'll also use the subtraction property. And the subtraction property is pretty much the same. It just says if we subtract the same number from each side, then the equations, both sides are equal as well. So if I subtract C from both sides, then these will also both be equal. Then there's the multiplication property of equality. If I multiply each side of an equation by the same number, then the two sides are equal. So if I multiply C on both sides, then these sides are still both equal. And anyone want to take a guess? Just a stab in the dark, what the division property says? That's right, if you divide both sides by the same number, then they are equal as well. However, this one does have one kind of side note, is that the number that you divide by cannot be 0, because you guys all know that we can't divide anything by 0. So if we divide both sides, as long as it's not 0, then both sides of those equations are equal. So these properties of equality are kind of what set the foundation for the whole concept of solving equations. First of all, an equation is a sentence. It's like a mathematical sentence. There's no like capital letter and then period and stuff like that, but it looks something like this. It's just a sentence that states that two quantities are equal. And the value of a variable that makes an equation true is called the solution of an equation. So here, x plus 2 equals 6. This is an equation. X equals 4 is also an equation. These are what we call equivalent equations because they have the same solution. So even though this just looks like a solution by itself, it is also technically an equation. If it has an equal sign, it's an equation. So these are equivalent equations, and what we're going to do is start with this equation and create an equivalent equation that gives us the solution to the equation. So we're going to go through several different examples, and these are on page 280 in your book. I'm sorry, I forgot to say it earlier, but page 280 is where you want to go right now and fill in these examples. Follow along. Make sure you are taking your notes, filling in your notes. I will be checking these, and your parents should be checking these as well and signing for you. But we're going to look in this section at just one-step equations. So that's nice because they're all just one step. There's only one thing we're going to have to do to solve. So when we solve an equation, we want to get the variable by itself. And again, we want to create an equivalent equation using all those properties of equality that we just looked at. So I want B by itself. And so we can use the subtraction property of equality to create an equivalent equation. If I subtract 8 from both sides, then these two sides will still be equal to each other because of the subtraction property. So I could subtract the same number from both sides of the equation, and I've created an equivalent equation, which is also my solution, negative 13. My Self is blocking the check button. So if we have another example, you can put this one in the margins. X plus 4 equals negative 3. Well, again, I have x plus 4. Since this is an addition problem, I'm going to use the subtraction problem of equality and subtract 4 from both sides of the equation. And the reason I subtract 4 is positive 4 and negative 4 add up to 0. So this just equals x. Bring down this equal sign, and negative 3 minus 4 is the same as negative 3 plus negative 4, and gives us negative 7. So we subtract 4 from both sides. Negative 3 minus 4, you should know your rules of integers by now. You can also use a calculator. Gives us negative 7. So x equals negative 7. And then we can check this. You can always check your answers. If I plug in negative 7 for x, negative 7 plus 4, does that equal negative 3? And in fact it does. So you can always check your answers to see if you're correct just by plugging in the value for x and seeing if both sides end up being equal. Okay? So take a quick second and do the problem at the bottom of page 280. Don't stop or don't continue until you have stopped, and do the check problem on page 280. So I'll give you a second to do that. And then we're going to look at one-step equations, one-step subtraction equations. So look at page 281 next, and we're going to go through a few more. If I have x minus 4 equals negative 2, if it's minus 4, then we want to add 4 to both sides of the equation. Okay, and this should say the addition property. This is a typo on here. This is the addition property of equality. Your book is correct. This screen is not. So page 281 in your book has the right thing written. But the addition property, if this is a minus 4, then we want to add 4 to both sides, because negative 4 and positive 4 cancel each other out. So the reason we do that is so that they will cancel each other out, and we end up with x equals negative 2 plus 4, which is positive 2 right there. And again, you can check your answers. If I want to know if I'm correct, let's replace x with 2. 2 minus 4, does that equal negative 2? And in fact it does. So we know we're correct. So you can always check your answers here. So you guys take a second and see if you can do the check problem on the middle of page 281. Just pause really quick and do the one on page 281. I won't do an extra example for that one. Oh no, what happened here? Where did that go? Hold on, I'll pause for a second. Alright, I got it back. So, next equations are one-step multiplication equations. So if my equation is negative 8 times y equals 24, then we're going to do the opposite. If we want to get y by itself, we're going to do the opposite or inverse operation. So since we're multiplying by y right now, we want to divide both sides by something to get the y by itself. So if you're multiplying times your variable, a number times your variable, then you want to divide. We're going to divide by this negative 8 that's in front of y. So we choose negative 8, and we divide both sides by negative 8, because whatever we do on one side, we have to do on the other. And since we're dividing both sides, we're creating an equivalent equation. And negative 8 divided by negative 8 is positive 1. So this is just a 1y here. And 24 divided by negative 8 is negative 3. Oops. All the negatives there. Okay. And again, we could just double check our answer. Negative 8 times negative 3, if we plug in negative 3, gives us positive 24. So you can check your solution that way. So try the problem on the bottom of, or excuse me, at the top of page 282. Go to the top of page 282 and try the check problem on the top there. Okay, another one-step equation uses the are the equations that we're dividing. So we have a divided by a number. So what property do you think we're going to use if our variable is being divided by a number? You guessed it, the multiplication property of equality. So now we're going to, if it's a divided by negative 4, I want to multiply both sides by negative 4. And negative 4 here And this, if you think about it, is like negative 4 over 1. So these would cross cancel. So all I have left on this side is just a. So again, the goal with solving equations is always to get the variable by itself. And whatever's happening to that variable, we're going to do the inverse of that. So if it's being divided, then we're going to multiply both sides. And that's going to help us get that variable by itself. And then negative 9 times negative 4 is positive 36. So see if you can do the one at the bottom of page 282. Okay, try that one. And then we're just going to look at one more problem for this video. So I hope you're pausing and trying those practice ones because that'll be good for you guys to do. The last thing for today is multiplicative inverse. Solving equations using the multiplicative inverse. So first of all, two numbers with a product of 1 are called reciprocals or multiplicative inverses. So I'll probably say reciprocal most of the time, but that's the same as multiplicative inverse. The inverse property can be used to solve equations involving rational number coefficients. So first of all, the reciprocal or multiplicative inverse, if the number is 1/2, then the multiplicative inverse, we just flip these, and it's 2 over 1. If the number is, I don't know why it always does this. All right, let's go back. Reset. If the number is, stop doing that. Just waste my time. If the number is 3/4, then the inverse is 4/3. And if I multiply 3/4 times 4/3, what do we get here? We get 1. 1/2 times 2 over 1 is 2 over 2, or just 1. So there are inverses, or multiplicative inverses, or reciprocals if, when we multiply them together, it equals 1. So that's what a multiplicative inverse is. The product of a number and its multiplicative inverse is 1. So if I have 7/8 and multiply it by 8/7, I get 1. If I have negative 3/2 and multiply it by negative 2/3, I get 1. And this is going to be helpful when we're solving equations like the one on page 283, example 5. So if we look at 283, example 5, we have your favorite fractions. I know you love working with fractions. But if we want to write this equation, or solve this equation for x, right now you see that it's this number times x equals some other number. Remember that when we multiply something by x, usually we divide both sides to get the x by itself. However, when that number is a fraction, we're going to approach it a little bit differently. So it's going to be helpful if we have it as just a fraction, not a mixed number. So any mixed numbers we would change to improper fractions. And then I'm going to use the multiplicative property of equality. I'm going to multiply both sides of the equation by the same number, okay? And the number I'm going to pick is the reciprocal of this number in front of x. So the reciprocal of this is negative 8/15. And I'm going to multiply both sides of this equation by negative 8/15. And what that does is this times this, anything times its reciprocal, we said equals what? Yes, 1. So that just equals 1 on this side. And on the right, when you multiply across, you can also cross cancel. They didn't do it this way. But if you were to cross cancel and simplify, you end up with negative 2 2/5 or negative 12/5 once this is all simplified. So the way we solve equations with fractions like this is to multiply by the multiplicative inverse. So let's look at another example. And you guys can write this on the margins of page 283. But if I want to solve 3/4 x equals 9, equals negative 9, then I'm going to multiply both sides of this equation by 4/3, the inverse, the multiplicative inverse of this number in front of x. So if this is 3/4 times x, I'm going to multiply both sides by 4/3, and what that does is these together, if I multiply those, equal just 1. But I don't have to write 1x, I could just write x. And then over here on this side, if I cross cancel, then this is just negative 12. So x equals negative 12. 3/4 times negative 12, you can check with a calculator, equals negative 9. So this is how we solve these equations. And you guys can stop and do the check problem on the bottom of page 283. And this is the end of part 1. So keep watching, pause for now, but keep watching for part 2. And I'm just going to keep going right at it. So you guys can stop now, but we're going to keep going And this next part is part 2. So you don't have to watch this till the next night. But we are going to go on with page 284. So part 2 starts at page 284. So when we have equations with decimal coefficients, you solve these the exact same way. If this is 0.25 times x, then we're just going to divide both sides by 0.25. So it's very simple. There's nothing new to learn. And you are able to use calculators, so this makes it even easier. If I have negative 17 divided by 0.25, then this actually ends up being negative 64. So you can use your calculators to solve this, but if it's a decimal, just you solve it the same way as if it was a regular number, okay? So let's look at another example. And on here, it's negative 2.8p equals 4.2. So again, we're just going to divide both sides by negative 2.8. The same way we would if it was just like negative 2. And for some reason, my 8s don't want to work and write correctly. But 4.2 divided by negative 2.8 is 1.5. And is that positive or negative 1.5? Correct, negative 1.5. I'm going to pretend that I hear you guys answering me and that you got the correct answer. Okay, so on page 284 in the middle is a check problem. Pause this and try that one really quick before you move on to our next type of problem. Now again, it's still a one-step equation, but we have fractions that we're working with. So when it says rational numbers really is any of the numbers we've looked at, but mostly they're talking about ones with fractions in them. So if I have x minus 3/10 equals negative 1/5, since I'm subtracting 3/10, okay, then we will add 3/10 to both sides. And this one kind of did two steps all at once. So if we add 3/10 to both sides and get a common denominator, so they rewrote negative 1/5 as negative 2/10, so that we would have a common denominator. Then negative 2/10 plus 3/10 is just 1/10. It's not letting me write right now. So 1/10 would be our answer right here. And this is also in the book on page 284 at the bottom there. X equals 1/10. Let's look at another example like this. Again, we solve these the same way. So it's W minus, so rational decimals or fractions, kind of essentially is what they're talking about here. W minus 4.3. So if I want to get W by itself and we're subtracting, then what's the inverse of subtraction? Right, addition. So we're going to add 4.3 to both sides. I don't know why this is not writing very well for me. But we're going to add 4.3. Good grief. So the same way we would add if it wasn't a decimal, you do the exact same thing with decimals and fractions. You solve the equations the exact same way. You just have decimals and fractions that you work with here. And negative 6.5 plus 4.3, I have one of each, so I should subtract those two numbers, and since my larger number is negative, then my answer is negative 1.7. So see if you can do the one at the bottom of page 284. Ugh. If this thing will write for me. Okay, now, where in the world? Oh, okay. Now, besides solving equations, you guys are also going to have to write your own equations and then solve them, okay? So, a lot of situations can be represented with equations. If the highest recorded temperature in Warsaw is 118, and this is 158 degrees greater than the city's lowest, what is the lowest recorded temperature? So let's kind of look what this one looks like here. And this is on page 285 if you're still following along in your book. So the highest recorded temperature is 158 greater than the lowest temperature. We don't know the lowest temperature, so let's call that T. And then we could say that T plus 158, the lowest temperature, plus 158 equals the highest temperature that we were given of 118. So then that's the equation. and then we're going to solve it by subtracting 158 from both sides. So the first part here on example 8 on page 286 is that you first have to write the equation and then solve it. Ooh, this one, look at the pretty animation here. The stingray is at a certain depth in the ocean. After ascending 5.5 feet, it's now at a depth of negative 14 5/6. So let's look at what's happening again. Here's the stingray. It goes up 5.5, and now it's negative 14 5/6 feet below the surface. So what was its initial depth? Okay, so our unknown is that initial depth, right? The initial depth plus 5.5 feet lands us at negative 14 5/6. So let's just call that initial depth the D. You can call it X. A lot of times we use X, but you can use a letter that represents kind of what it is. So D for depth kind of makes sense here. And so then the equation we would write is that the depth, then we go up 5.5 feet, and we end up at negative 14 5/6. So does that make sense, hopefully, where this equation comes from? Okay. And then we would go on from here and solve the equation. So once you write the equation, then we solve the equation. First we write it, then we solve it. We write it, then we solve it. Write it, solve it, write it, solve it, write it, solve it. You can't solve it before you write it. Okay. So, if I have D plus 5 1/2, then to get the D by itself, we would subtract 5 1/2. But we'll pick a form of 5 1/2 that has a common denominator, so we can subtract these two numbers here. Now, since these are both negative, a negative minus 5 3/6, we have to actually add these together. So this would be 19 8/6, which again, if we simplify this, is going to be negative 20 1/3 when it's all said and done. Let's look at another example of this one. So the temperature changes at a constant rate of negative 2 degrees Fahrenheit each hour. After several hours, the temperature changed by negative 8 degrees Fahrenheit. Write and solve an equation to determine the number of hours the temperature decreased. So this temperature is changing at a rate of 2 degrees each hour. So we can write that as negative 2 times h, 2 degrees for each hour that goes by. And the total temperature change was negative 8. So in this case, it's a multiplication equation. Negative 2h equals 8. And then we will divide both sides by negative 2, because the inverse of multiplying is dividing. So we will divide, and we get that h equals positive 4. Okay, so see if you can do the check problem at the bottom of page 286. Check problem, page 286. Take some time with this one. I really want you guys to spend some time and try this. Read it carefully. See if you can write the equation. Actually, they give you multiple choice, so just figure out which one it is. But do spend some time actually doing this problem, working through it, and then if there's any questions on any of these, we can go over them in class tomorrow. Okay, you guys? I hope you enjoyed my new do for 2023. Don't forget to comment down below what you think, and if you want hair like this, let me know what you think. I can let you know who my stylist is. Okay, all right, that's all for now.